Minerals are inorganic, naturally occurring substances that have a characteristic chemical composition, distinctive physical properties, and crystalline structure. What we're going to do in lab is concentrate on these 2 points, distinctive physical properties and crystalline structure. What we're going to do today in this laboratory is you are going to turn yourself into kind of like a computer. You may think that identifying minerals, you just look at it and you say, oh, it's that. But that's not the case. What we're going to do is we're going to do a series of tests on each one of these minerals. And then what you're going to do is, by process of elimination, almost acting like a computer, where you go to if-then statements. If it does this, then it must go to the next step. If it doesn't do that, we go to this step. What you're going to do is you are going to sit down, do the tests, and then figure out which mineral is which. One of the first instincts you're going to have is to be able to look at stuff and be able to tell me what things are purely based on what they look like. And that can be good, but a lot of times that can be really misleading. For example, I have a couple of minerals up here. These minerals down here are all the same. This is all potassium feldspar, pink, green, white, yet it's all the same mineral. Same with quartz. We have rose quartz, which is pink, white quartz, clear quartz, purple quartz, amethyst, gray quartz. Here's 2 that look the same. You might say, oh, those are exactly the same mineral. But look at what happens when I scrape my thumbnail across. It scratches. This one, I scrape my thumbnail across, nothing happens. So these are clearly different minerals. Instead of just looking at minerals and saying, oh, it kind of looks like this, what we're going to do then is a series of tests where we definitively figure out which the mineral is. First test is going to be luster, okay, whether a mineral is non-metallic or metallic. And if you look at these samples down here, you will see a bunch of on this side which look like they are pieces of metal. So they have a distinctive look to them like they're metal. Whereas over here, these clearly do not look like metals. Okay, and so therefore, that's the first test. Do they look like a metal or do they not look like a metal? And that way we can separate one group of minerals from another. Once you've determined whether it's a metallic luster or whether it's not a metallic luster, then you turn to the page in your book where it has a group of minerals that all have metallic luster, as opposed to the group of minerals which have non-metallic luster. That means that the mineral you've looked at, if you've determined that it's metallic, has to have come from this group, as opposed to if it's non-metallic, it has to have come from that group. And therefore, you can start to eliminate down what the mineral is. Once you've figured out luster, the next thing we're going to do is try to talk about hardness, okay? And you will see in your book there is a chart on what is called Mohs hardness scale. Now this is a relative scale of minerals of how hard they are. Now you might think hardness is the ability not to break into pieces when you smash it. Not so. It's the ability not to be scratched. You'll notice that the hardest mineral on Mohs hardness scale is diamond. If you have a diamond, you try to smash it with a hammer, it will smash. However, nothing will scratch it. And so therefore it's the resistance to scratching. Now we have a whole list of minerals that are here, and we will see that we have some minerals down in this little tray here which match those lists minus the diamond. Okay, and in the list then, these are relative hardness. The softer stuff will be down like in talc and gypsum and things like that, whereas diamond are the hardest thing, corundum. Notice those were all gemstones that are in the hardest side. Why is that? You don't want your gemstones getting all scratched up if you take them out. And so therefore gemstones tend to be hard. Things that are not tend to be soft. Okay, and so what we're going to do is look at the hardness of some relative things. You do not have a mineral kit. This is the mineral kit. It's got this several groups of minerals all listed on Mohs hardness scale, which you should pay attention to and memorize. However, you are also handed a kit in this lab, and this kit contains some common things, and their hardnesses will also shown on this chart. One of the things you have is a streak plate, and notice the streak plate has a hardness of 6.5. Second thing we have is a glass plate. Glass plate, as you can see, is a 5.5. Anything that this can scratch must be softer than 5.5 on Mohs hardness scale. Anything that scratches it is harder. Next down the list is a probe. Okay, this is a piece of metal in here, a wire. And you can see on here that that comes in at 4.5. So this again, harder than this would scratch it. It would scratch anything softer. At 3.5 we have a copper penny, and you can't use pennies now because they're not all copper. You've got to use the one that we give you. And that comes in at 3.5. Below that, you can use your fingernail. Fingernail has a hardness of 2.5. And so therefore, with these common things, we don't have to deal with that Mohs hardness scale minerals. Next thing we have to do is to take a look and figure out the hardness of a mineral. So for example, if I start with this glass plate, I'm tilting it up. The way I'd rather have you do it is to hold it down on the table. What we're going to do then is take a mineral and we're going to scratch it against the plate. And notice that I have left a scratch on the plate. Even when I rub it off, that scratch is still there. That means this mineral is harder than that plate. Okay, now let's take a look at if we took another mineral and see what would happen if I scratch it next to it. And now you can see it looks like it might be scratched, but when I rub it, the whole thing comes off. And so therefore, this mineral is softer than the glass plate, but this mineral is harder than the glass plate. If we try it with this mineral, you can see that it does not leave any scratch at all. Okay, and so this mineral is definitely softer, this one is harder. Test with the glass, we found out that this mineral was clearly harder than the glass. These other two, not so easy to say. So what we can try next is the wire probe. The wire probe has a hardness of 4.5. So what we will do is try this one first, and we can see clearly that the wire probe scratches the mineral. And so therefore, this mineral is softer than 4.5. On the other hand, this mineral here, we can try with the wire probe, and clearly it does not scratch the mineral. So this mineral is harder than 4.5. And so therefore now we are starting to get what the hardness of each of these minerals is. So the next thing we can do is with the copper penny. And with copper penny then we can scratch the mineral and see if it scratches that. And as we can see, this is not scratching it really, but we're getting close to the right hardness for the mineral. I can then use my thumbnail, and clearly it doesn't get scratched by my thumbnail either. So this mineral is on the order of 3 to 3.5 in hardness. The next step we can do is to test for what is called streak. Now remember before I told you that color is no good, and color isn't any good. However, streak is, and streak is a measure of the color of the mineral. So what we're going to do is you have two plates that are in your kit. One of them is a dark colored plate, one of them is a light colored plate. You just basically can choose to use either one depending on the basic color of the mineral. Now a lot of times minerals will show up the color just as you figured they would. So for example, if I scratch that against here, you can see it leaves a yellow streak just as you would have expected. Even more impressive are things like this, which is graphite. Graphite, obviously, we have in our pencils, and certainly it just draws on the streak plate. So there are some streaks that would be expected. On the other hand, if we use something like this, which is kind of a bronzy color to it, when we run the streak of it, notice how it is gray. So therefore, the streak does not always show the same color as the mineral itself. Even more impressive is something like this mineral. These minerals are actually the same mineral. The only way you could tell is by doing a streak. Notice that it gets kind of a brown streak, and so does this. So you get two brown streaks out of these minerals which don't look anything alike, and yet they have the same streak. Most minerals will have a white streak, and so you have a mineral like this, and you have just a plain white streak. The next step in our sequence of figuring out what things are is to look for what is called cleavage in a mineral. Cleavage or fracture, any mineral can have. And what these are planes that are repeating throughout the mineral. That's cleavage. If they have no planes, if you get kind of a rounded shape to the breaks as opposed to a flat shape to the breaks, then it has what's called fracture. So fracture is rounded, cleavage is planar. And these planes must go throughout the mineral. And we'll see what a good example of cleavage is here. This is mica. Mica has one perfect cleavage to it. And what this means is that you can peel away the planes of the mica, and it will just constantly repeat and keep peeling away the same way. These are the cleavage planes of the mineral. This is the best example of cleavage, and you can see how the light glints off of the surface of this mica. Other minerals don't have such perfect cleavage, and they may have different cleavage directions, so they may not be quite the same as mica. You use it the same way. You try to glint the cleavage off of the light so you can see which way cleavage goes. This one you can see has it in this direction, and if we keep rotating it around, you will see cleavage in this other direction. Therefore, this has two cleavage planes at a relatively high angle to each other, something about 60 degrees. Here's yet another mineral. We do the same thing. We rotate it around until we see that glinting of the light off of the cleavage planes, all parallel to each other, and so we can see that we have at least one cleavage direction here. As we rotate it around, we can find that in this sample, we actually have 3 different cleavage planes. And if you look through your chart in your book, you will see that there are different organizations to these cleavage planes, different geometries, and that can be very distinctive for being able to tell which mineral is which. Now here's a complication to the whole thing. Instead of just having cleavage to look at for planes and minerals, you can also have other planes that have nothing to do with cleavage, and these are what are called crystal form. So you can have these beautiful crystals here that also seem to have planes on the outside, but that's all. They only have the planes on the outside of the mineral. Inside the mineral, they will break apart in a completely different manner. So for example, this mineral of fluorite has a very nice, even mineral shape to it, but inside it will not break the same way. Even better is this piece of quartz, and quartz makes a beautiful crystal with nice flat edges on the outside, but if you break it apart, notice the inside looks like this broken piece with all of these fractured surfaces. So quartz has no cleavage, it has fracture, even though it makes such nice crystals on the outside. Finally, there are a group of distinctive properties to specific minerals. So you may have gone through all of these other properties and figured out everything and got it down to the last point, and there may be one last property that you might have to use to be able to determine it. Now sometimes it's going to be that cleavage angles or how many cleavages will tell you what they are, or even the color of the streak and things like that may be distinctive to tell you exactly what the mineral is. But in other cases it may not be. And some of those things we can talk about here. First of all, there may be things like what is called specific gravity. Is a mineral heavy to the touch or is it light? So you might be able to pick up 2 minerals and say, wow, this one's a lot denser than this one is. So just specific gravity may be able to help you to determine what the mineral is. On the other hand, there may be some other relatively easy things to do. For example, this mineral, if you scratch it up using another mineral or a plate or anything else, and sniff it, it smells. This is sulfur, so you get a sulfury smell on it to be able to tell you what the mineral is. Otherwise, we have a mineral like this. This is the mineral halite. You know what halite is? It's table salt. Sure enough, it tastes like table salt. So taste might be another way to determine what mineral is what. Other things on these minerals, this is the mineral calcite. You can get a bottle of dilute hydrochloric acid from your lab assistant, and what you will do is put a drop on top and it will fizz if it is calcite. Calcite is the only mineral that will fizz when you put the drop directly on. Other minerals might be magnetite, and magnetite, you have a magnet in your kit, a little magnet, we put it on and the magnet holds, and so therefore that is magnetite. It's the only mineral that will do that. Other things might be on this mineral, which is plagioclase. Plagioclase tends to have what are called striations, which looks like someone took a knife and cut it over the surface of the mineral. So that is another distinctive characteristic. Potassium feldspar commonly has little veins running through it. So the color is not even, but has veins of color running through it. And so therefore, these are several of the different ways you can look at these. If you think for all the world you got calcite, but it's not fizzing when you put that acid on it, there's one other mineral it might be. It could be the mineral dolomite. Dolomite will, however, fizz only in the powdered form. So what you need to do is to take your sample, rub it on the streak plate until you get a little streak on there, and that will be powder. Drop the acid on that, and that will fizz. That's the only way it will work. If it doesn't fizz here first, try that second. Oh, will this guy ever stop talking? God, I'm tired. I want to get out of this. When is this class over? Oh, sorry. Now I'm being a student, see? And so therefore now what I'm going to do is I'm going to go through the whole way of how we figure out what mineral is what with you. So we're going to take an unknown, and we're going to go through the whole step-by-step process, fill in a form, and then I'm going to show you how it's all done. Okay, first thing is we have our kit, and we have our book, we have our form to fill out, and we have our unknown mineral. And this is our unknown mineral. So what we're going to do is go through step by step. So first thing, since I'm a student, I'll say, how does he expect us to be able to figure this out? All right, so how do I expect him to be able to figure it out? First thing, let's start the first test. Is this mineral a metallic luster mineral, or is it a non-metallic luster? Well, certainly this doesn't look like a piece of metal. So let's start off with step one, it's not metallic. Second test I'm going to do, I already said that it's a non-metallic luster. I'm going to look at the hardness of the mineral. So let's see, what's the hardest thing in my kit? My kit has a streak plate in it, and the streak plates have a hardness of 6.5. So let's try the streak plate, and it makes a mark on the streak plate, but as soon as I rub it off, it disappears. So therefore, it is not as hard as the streak plate. Let's try the glass plate. Glass plate has a hardness of 5.5. And it indeed did scratch the glass plate, so it's harder than 5.5. I don't even have to bother with the rest of them because I already know that the hardness is someplace about 6. Okay, so we got luster, we got hardness. What's the next thing? It says on the chart, look for the cleavage. Okay, so what we're going to do then is we're going to rotate this around and try to glint the light off of some of these surfaces and see if we see any cleavage planes. I see one clear cleavage plane in this direction, and I rotate it around, and there's another one in that direction. So now I see two cleavages at about 90 degrees to each other, and I don't see any other cleavages throughout the mineral. Well, there's one that's parallel to this one, so I can see them on opposite sides of that mineral, but clearly I have two directions of cleavage at approximately 90 degrees to each other. Now I'm looking at my chart, I'm figuring out what this is, and I've gotten through that the luster is non-metallic, a pretty hard mineral, hardness of 6, I got cleavage in two directions. I can go through, I have two things that it's down to. It's either potassium feldspar or plagioclase feldspar. Those are my two possibilities. One of them has striations on the surface, and so I can look for striations, and the other one, as I know from before, might have little lines in it, but it will not have those knife marks on the surface. So what I'm going to do then is I'm going to take this sample and I'm going to look closely to see if I can find the striations. And clearly we don't have the knife marks on the surface. However, we do have these little vein-like lines cutting through it, and so therefore this one I will conclude is potassium feldspar. Okay, now that I've completed all of my tests, it's time for me to fill out this chart, which I will hand in to my lab TA for grading. And so therefore, I want to be able to fill out all the columns in here. The first column, it says, what's the luster or color? So here I see that it's a non-metallic. The color is white. Second column asks me what the streak is. I would take my sample, run it on the streak plate, and find out that the streak is white. We have already determined that the hardness of this mineral was a 6. This next thing is cleavage and fracture. We determined that it has two directions of cleavage, and they were at about 90 degrees to each other. Crystal form, well, we didn't see any crystal form. This is not a crystal substance, so therefore we write none. Specific gravity, it's relatively light. And we've determined using this book that it's potassium feldspar. Now this last column, which is for most distinguishing properties, is the most important of all to you, because you are going to have, at a future time, at your midterm exam, you're going to have to be given a bunch of unknown samples, and you're going to have to be able to determine what they are without the use of your book. So here what you need to put in this is to be able to give it a distinguishing feature, so that in the future you look at it and you say, oh yes, that's potassium feldspar. And therefore it may be one of the things that are already on this chart. It may be the cleavage that gave it away to you, or the color, or whatever it was. It could be on the chart, or perhaps it wasn't. In this case, one of the things that didn't go on the chart was that it had those little white veins on the cleavage surface. And therefore maybe you want to write the white veins in here. Or maybe you want to write that it's the cleavage that gave it away. Whatever it is to you, it's so that you can identify this mineral in the future, and that you can study for the exam and get 100%, as I expect you all to do.